So I would like to move now to the presentation from CNSC staff is outlined in CMD 18H4 and 18H4.A. And I said, Mr. Frappier, you'll make the presentation. You may proceed.
Thank you. Thank you, and good afternoon, Mr. President, members of the Commission, and staff would like to welcome the new Commission members, and you can rest assured our job is to ensure that you have all the information you need to make a decision. So if we're not doing that, please fill in the blanks with questions. We're quite keen on that. As I said, my name is Jerry Frappier, and I'm the Director General of the Directorate of Power Reactor Regulations at the CNSC. With me today are Mr. Luc Sigouin, Director of the Bruce Regulatory Program Division, Mr. Ken Lund, Senior Regulatory Program Officer of the same division. As well, we have regulatory and technical staff from the CNSC who are present and available to answer any questions the Commission might have. This presentation provides information in relation to the renewal of the Bruce A and B Power Reactor Operating License, provides a summary as well as highlights from the CNSC staff's written submission, which is found in CMD 18H4. As you can see from the outline, this presentation focuses on CNSC staff's regulatory oversight and assessment of Bruce Power's performance. I will go over the purpose of the hearing and provide a brief background for Bruce A and B. The Commission granted Bruce Power its first license to operate the Bruce A and B stations in 2001. Before this, the station has been operated by Ontario Hydro under licenses from the AECB. The most recent hearing was conducted by the Commission in 2015. This hearing represents the 6th license renewal request to the Commission. In June 2017, Bruce Power submitted a request to the Commission to renew its power operating license for a period of 10 years, which encompasses operation as well as activities related to refurbishment, which Bruce Power refers to as Major Component Replacement, or MCR. In support of the license application and activities associated with refurbishment, Bruce Power has also completed a periodic safety review, or PSR, in accordance with the CNSC's regulatory document, Reg Doc 2.3.3 on periodic safety reviews. In its application, Bruce Power is requesting the Commission to approve operations of Bruce A and B up to a maximum of 300,000 equivalent full power hours. The current license allows for operations up to 247,000 EFPH. Bruce Power is also requesting the Commission to accept the scope of the refurbishment project as identified in the Integrated Implementation Plan. And lastly, Bruce Power is requesting the consolidation of the Class 2 nuclear facilities and nuclear substance and radiation device licensors for them to be folded into the Power Reactor Operating License. Very quick little bit of background. I know Bruce already did some, but we'll just go over a couple of slides from our perspective. Bruce Power is located in the municipality of Kincardine in the county of Bruce, Ontario. The Bruce A and B stations are part of the Bruce Nuclear Power Development Site on the shores of Lake Huron. While Ontario Power Generation owns the Bruce A and B stations, Bruce Power operates these stations under a lease agreement with the Ontario Power Generation. The Bruce station consists of 4 750 megawatt CANDU reactors, which came into service between 1977 and 1979. The Bruce B station consists of 4 817 megawatt CANDU reactors, which came into force or into service between 1984 and 1987. All 8 units are currently operational. Bruce A units 1 and 2 were refurbished and returned to service in 2012. In 2015, the Commission issued a combined license for Bruce A and B, and the current A and B operating license expires on May 31st, 2020. As previously mentioned, Bruce Power has requested a 10-year license. The proposed 10-year license period encompasses operations as well as activities related to refurbishments, which is planned to begin in 2020. In order to ensure that the scope of the refurbishment activities are defined prior to the beginning of the first outage, Bruce Power has requested to update the licensing basis in 2018, 2 years ahead of the expiry of the current license. Commission member document CMD 18H4 provides CNSC staff's conclusion and recommendation to support the Commission's decision on the license renewal application. The CMD provides information on all 14 of CNSC's safety and control areas, with focused highlights on CNSC staff's environmental assessment under the Nuclear Safety Control Act, Bruce Power's environmental risk assessment and predictive environmental risk assessment, the refurbishment program itself, the periodic safety review, fitness for service for major components, an update on the Fukushima action items, and engagement with Indigenous groups. CNSC staff's conclusion and recommendations are based on the assessment of Bruce Power's submitted license application and the supporting information, the licensee's past performance in all 14 safety control areas, other matters of regulatory interest such as the Fisheries Act authorization, licensee's public information program, and Indigenous peoples consultation and engagement activities. I will now pass the presentation over to Mr. Sigouin, who will discuss CNSC's regulatory oversight, Bruce Power's periodic safety review, and major component replacement project, and an overview of Bruce Power's performance assessment in the 14 safety control areas.
Thank you, Mr. Frappier. Mr. President, members of the Commission, my name is Luc Sigouin. I'm the Director of the Bruce Regulatory Program Division here at the CNSC. The CNSC has a clear and robust regulatory framework in place to ensure the continued safe operation of nuclear facilities. Regulatory oversight is maintained to ensure that licensees operate in a safe manner. Regular inspections and evaluations verify that licensees are complying with the applicable laws and regulations as well as the conditions of their license. The link between the license and the license conditions handbook will be discussed later in the presentation. The CNSC compliance verification approach includes activities to assess and verify compliance, as well as graduated enforcement actions to address instances of non-compliance. As such, action items raised by CNSC staff require licensees to implement corrective actions to address items of non-compliance. Licensees are required to report events in accordance with Reg Doc 311 reporting requirements for nuclear power plants. The types of reports submitted by Bruce Power include, for example, quarterly reports on safety performance indicators, an annual report on environmental protection, an annual report on fuel monitoring and inspection, and unplanned event reports. CNSC staff review all events, compliance, and performance reports, as well as results of ongoing monitoring activities. The results of the reviews are reported to the Commission through the annual Regulatory Oversight Report for nuclear power plants, as well as during regular status updates at Commission meetings and hearings. CNSC staff conduct compliance activities which include reviews, walkdowns, and inspections. In addition, routine surveillance and monitoring activities are conducted above and beyond the walkdowns and inspections to provide further verification that the plant is operating in accordance with regulatory requirements. Surveillance and monitoring consists of on-site activities such as attending licensee meetings, reviewing logs, reviewing problem identification databases, and having formal and informal discussions with licensee staff. Any deficiencies or areas of improvements identified by CNSC staff were addressed by Bruce Power. Bruce Power maintains a robust management system that includes a problem identification and corrective action program. Problems or issues identified are documented in Bruce Power's Station Condition Record System, or SCR, to ensure that appropriate actions are taken. CNSC staff perform routine reviews of the Station Condition Record System. Most of the station condition records identified were of low risk significance and do not require a formal corrective action plan to resolve the issue. Directives, action notices, or recommendations raised by CNSC staff from reviews or inspections are tracked to completion by staff. The results of inspections indicated that Bruce Power has made adequate provisions for the protection of the environment and the health of persons. Bruce Power is responsible for ensuring safe operation of the stations, and CNSC staff independently verify Bruce Power's performance. CNSC site inspectors carry out daily walkdowns as well as inspections with specialist staff from Ottawa, following the CNSC Risk-Informed Baseline Compliance Program. The regulatory efforts can be adjusted depending on the performance of the licensee, as well as the need to oversee special projects such as refurbishment. As shown in this table, the compliance verification activities by CNSC site inspectors during the current licensing period comprised of Reg Doc 311 event reports, reviews, walkdowns, and inspections. These activities represent an average of 1,700 person days of effort per year at the Bruce site, with over 5,000 total person days of effort per year spent on all Bruce regulatory compliance activities. The reported numbers in 2015 were lower at site compared to other years, as CNSC site staff efforts were shifted towards activities required to support the 2015 license renewal. CNSC did not identify any significant findings as a result of the compliance activities that were performed at Bruce A and B. I'll now go over the periodic safety review that Bruce Power conducted in support of its license application. CNSC Reg Doc 233 on periodic safety review contains CNSC's regulatory expectations for conducting a periodic safety review, or a PSR. A periodic safety review is a comprehensive evaluation of the design, condition, and operation of a nuclear power plant. A PSR involves an assessment of the current state of the plant as well as plant performance to determine to the extent to which the NPP conforms to modern standards and best practices, and to identify any factors that would limit safe, long-term operation. This enables the determination of reasonable and practical modifications that should be made to the plant or programs to enhance the safety of the facility to a level approaching that of a new NPP, and to allow for safe, long-term operation. In accordance with international practice, 10 years is considered an appropriate interval between PSRs. CNSC Reg Doc 233 provides the 4 phases of conducting a periodic safety review. The first phase is the PSR basis document, which documents the agreement between the regulator and the licensee on how the PSR will be conducted. The second phase is to prepare safety factor reports, which contain the detailed technical assessments that compare the plant and programs to the modern standards. In the third phase, the Global Assessment Report summarizes the findings of the safety factor reports to provide an overall assessment of the safety of the plant and identify practical actions that can be implemented to improve the plant. As the final step, these safety improvement actions are then included in the Integrated Implementation Plan. The conduct of a PSR is intended to be a requirement that can be aligned and repeated with license renewal and form part of a licensing basis for a regulated facility. In 2014, Bruce Power began its work on PSR with a focus on Bruce A. In 2015, when Bruce Power reached an agreement with the Ontario government for refurbishment, the scope was expanded to include Bruce B. Bruce Power's work on PSR took place over a 3-year period, with the final Integrated Improvement Plan submitted to CNSC staff in 2017. The Bruce Power PSR addressed 64 modern standards. The list of modern standards and practices submitted in the PSR were assessed and accepted by CNSC staff through the approval of the PSR basis document. CNSC staff have concluded that Bruce Power identified all the strengths and gaps in the safety factor reports, that the results of the safety factor review were incorporated into the Global Assessment Report, and that the improvements needed to address the gaps are all identified in the Integrated Implementation Plan. The Integrated Implementation Plan, or IIP, presents the proposed safety improvements and includes timeframes for implementation. Bruce Power identified 191 improvements in their implementation plan, with defined completion dates. The IIP was accepted by CNSC staff in September 2017. Some examples of the major activities identified in the IIP include the replacement of major components such as fuel channels, steam generators, and feeders, the installation of a containment filtered venting system to address lessons learned from the Fukushima accident, and upgrades to fire protection systems, including detection, fire water supply, and sprinkler systems. The 191 identified improvements will be implemented during scheduled maintenance outages or during extended refurbishment outages. Staff conclude that Bruce Power has identified corrective actions and improvements to improve the level of safety over the next licensing period. The proposed safety improvements have all been captured in the IIP. In concluding the PSR discussion, CNSC staff reviewed and submitted information and determined that Bruce Power's PSR met the requirements of Reg Doc 233 on periodic safety review. Bruce Power has systematically reviewed the current state of the plant against modern standards and practices and has identified the improvements that need to be made to Bruce A and Bruce B. CNSC staff will report annually on the status of all IIP commitments to the Commission through the annual Regulatory Oversight Report for NPPs. I will now go over CNSC staff's review of the Bruce Power refurbishment project. As you've already heard from Bruce Power, the refurbishment work differs slightly from previous projects, and that work is divided into two categories: major component replacement work and asset management work. The major component work includes the replacement of fuel channels, steam generators, and feeders. The replacement of these major components requires significant field time and requires the reactor to be placed in a defueled and dewatered state. Asset management work includes the replacement of other components and is generally not considered to be on the critical path of refurbishment activities. The work can be completed during a scheduled outage, or when the unit is online, or during an extended MCR outage. Some examples of asset management work include inspections of calandria vessels, replacement of maintenance cooling heat exchangers, and replacement of some electrical components. As previously stated, Bruce Power reached an agreement with the Province of Ontario on refurbishment in 2015. This slide provides the approximate time frame for refurbishment of the Bruce units, starting with Bruce B, Unit 6 in 2020. Refurbishment would continue until 2033, with Unit 8 being the final unit. The current requested license period would expire in 2028. Pending the licensing decision by the Commission, Bruce Power would need to submit a new application prior to the start of refurbishments of Units 7 and 8. Following refurbishment of a unit, the licensee is required to perform commissioning tests to demonstrate that the reactor facility can operate in the modes for which it had been designed. Bruce Power is required to demonstrate that the associated work meets specified requirements and to ensure that documentation has been updated appropriately. Similar to other refurbishment projects, CNSC staff identified 4 regulatory hold points for the return to service of each unit undergoing refurbishment work. These hold points include prior to fuel load, prior to removal of guaranteed shutdown state, prior to exceeding 1% full power, and prior to exceeding 35% full power. These hold points would serve as regulatory verification to ensure that all commitments have been met for staged increases in reactor power. Prerequisite commitments for each regulatory hold point are included in the draft License Conditions Handbook. CNSC staff are recommending that the approval to remove regulatory hold points be delegated to the Executive Vice President and Chief Regulatory Operations Officer of the CNSC. For reference, a similar delegation of authority was previously granted for the Darlington refurbishment, the Point Lepreau refurbishment, and also for the Bruce Power Units 1 and 2 refurbishment projects. Bruce Power's asset management program is a living program which will play a key role in managing the aging of the facility. It includes safety system tests, periodic inspections, system and component health monitoring, and life cycle management plans. The aging assessments of assets will be performed on a periodic basis and will consider inputs such as equipment failures, maintenance backlogs, performance trends, and obsolescence issues. Asset management is an adaptive approach which allows adjustments to be made in the maintenance strategies based on the condition of structures, systems, and components. If inspection results show faster than expected degradation, then a replacement may take place earlier than initially planned, and inspection frequencies can be increased. If the inspection results show that degradation effects are minor, then the replacement may be made at a later date. CNSC staff have reviewed the asset management program as part of the periodic safety review, and the implementation of the asset management program has been included in the integrated improvement plan. CNSC staff determined that the conditions of structures, systems, and components were adequately assessed, and that plans are in place to manage the conditions of structures, systems, and components, including aging-related degradation mechanisms. In concluding the refurbishment discussion, CNSC staff did not identify factors which would limit safe operation over the next license period. In addition to major component replacement, the asset management program will support long-term planning for the continued operation of Bruce A and B pending future licensing decisions by the Commission. Bruce Power has programs and processes in place to safely manage refurbishment work. CNSC staff will maintain oversight of the programs by conducting detailed refurbishment reviews and inspections. The reviews and inspections will focus on topics such as project execution, contractor and project management, and training programs. Regulatory hold points will ensure operational readiness of structures, systems, and components for the return to full power operation. The hold points would serve as regulatory verification to ensure prerequisite commitments have been met for stage increases in reactor power. Given that the refurbishment work will span several years, CNSC staff will provide updates to the Commission on the status of the project through the annual Regulatory Oversight Report for NPPs and the status updates on power reactors. I'll now provide an overview of CNSC staff's performance assessment of Bruce Power in the 14 safety and control areas. This slide provides a summary of the Bruce A and B plant ratings over the current license period for the 14 safety and control areas. It should be noted that the 2014 ratings are included in the slide for trending purposes. CNSC staff continues to report on the performance of Bruce A and B separately, even after the licenses were combined into a single license in 2015. Although many of the programs, processes, and procedures are shared between Bruce A and B, each station has its own separate work crews, and the stations differ in design, as Bruce B was built 7 years after Bruce A. The ratings for 2017 are not available at this time, as CNSC staff are still working on compiling the findings. Based on preliminary results, however, CNSC staff do not expect the ratings to change in 2017. This slide provides some of the highlights on Bruce Power's performance over the current licensing period. Bruce Power meets regulatory requirements in all SCAs and received a satisfactory rating or higher in each safety and control area. No workers or members of the public received radiation doses in excess of the regulatory limits, and all radiological releases were well below regulatory limits. Releases of nuclear and hazardous substances are assessed, controlled, and monitored. Licensee programs are implemented and maintained effectively and in accordance with regulatory requirements. Safety enhancements and improvements continue to be made during the current licensing period. As previously mentioned, the regulatory focus areas include the 14 safety and control areas, as well as other matters of regulatory interest. In assessing the license application, all safety and control areas were assessed. CMD 18-H4 presents CNSC staff's assessment for each of the areas in detail. For the purpose of the presentation, we will focus on 7 safety and control areas in particular. I will now pass the presentation on to Mr. Lunn, who will provide focused highlights on these 7 areas as identified in the slide.
Thank you, Mr. Seguin. Mr. President and members of the Commission, my name is Ken Lunn. I'm the Senior Regulatory Program Officer of the Bruce Regulatory Program Division. The Human Performance Management SCA covers activities to ensure that workers have the necessary knowledge, skills, procedures, and tools in place to safely carry out their duties. Minimum shift complement was maintained at Bruce A and B. Following the return to service of Bruce A Units 1 and 2 in 2012, additional certified staff were required to operate those units. While minimum complement was maintained at Bruce A, some positions were occasionally required to exceed the limits of hours of work. This can have a potential impact on worker safety, on worker fatigue, and could lead to the impairment of the performance of workers who are performing safety-sensitive work. As a result, Bruce Power made enhancements to its processes to manage worker fatigue. In addition, Bruce Power continued to hire and train more qualified operators. In 2017, the number of limits of hours of work exceedance was reduced compared to previous years. The Safety Analysis SCA covers the maintenance of safety analysis that supports the overall safety case for the facility. Bruce Power effectively managed deterministic and probabilistic safety analysis programs. I will provide highlights on the probabilistic aspects in the next few slides. Probabilistic safety assessment, or PSA, complements the deterministic safety analysis by integrating information about plant design, operations, component reliability, and human actions. It includes the assessment of the adequacy of the protection of the plant against internal and external hazards, such as internal fire or flood, seismic event, or high winds. The 2014 PSA results, which form part of the current licensing basis, were reviewed and accepted by CNSC staff. The results showed safety goal limits for Bruce A and B were met for both severe core damage frequency and large release frequency. In the 2017 license application, Bruce Power provided estimated PSA data, which include planned improvements to enhance the safety of the plant. The estimated PSA data was provided for information only and showed improved numbers for large release frequency. CNSC staff will review the detailed modeling of the plant station improvements as part of the next PSA update, expected to be submitted in 2019. The PSA results are reviewed and updated on a 5-year basis. It is also being updated as part of the implementation of Reg Doc 242 on probabilistic safety assessment. It will supersede the 2014 PSA upon acceptance by CNSC staff. In CNSC staff's written CMD, it is stated that Bruce Power will develop a process to consider further enhancement should be made if the PSA results are between safety goal limit and safety goal target. The process has now been developed. CNSC staff performed a high-level review of the document and determined that the process is consistent with industry's practice. An example of planned enhancements include upgrades to the fire protection system to improve the internal fire event PSA results. In this slide, the existing 2014 PSA results are shown in the 2 left-hand columns. The estimated data with planned improvements are shown in the 2 right-hand columns. The estimated data showed improved large release frequency results, taking planned improvements into consideration. To summarize, the 2014 PSA results have been reviewed and accepted by CNSC staff. The safety goal limits for severe core damage frequency and large release frequency were met. Bruce Power will submit the new PSA results in 2019 that includes station enhancement as part of the implementation of Reg Doc 242 on probabilistic safety assessment. The Fitness for Service SCA covers activities that impact on the physical condition of structures, systems, and components, or SSCs, to ensure that they remain effective over time. Bruce Power has programs in place to manage aging SSCs in accordance with Reg Doc 263 on aging management. Managing the aging of major components is integral in ensuring safe long-term operations. Specifically, Bruce Power developed life cycle management plans to manage the aging of major components. The plans include items such as evaluation of the component's aging degradation mechanisms, inspection methods, and repairs or replacement strategies. For example, feeders can be replaced if they do not meet structural margins prior to refurbishment. Aspects related to aging management of fuel channels to allow continued operation up to 300,000 equivalent full power hour will be discussed later on in the presentation. Conventional Health and Safety SCA covers the implementation of a program to manage workplace safety hazards and to protect personnel and equipment. 2 worker injury events at Bruce B were reported to the Commission in the current licensing period. The first event was related to a hydrogen flash, which occurred in 2016, while the second event was related to an electrical burn in 2017. The events resulted in the SCA rating being downgraded in 2016 to satisfactory and will remain satisfactory in 2017. The events are described in further detail in CNSC staff's written CMD. In both cases, CNSC staff conducted focus inspection to ensure that Bruce Power took corrective actions to prevent the recurrence of the events. Despite these injuries, the accident frequency rate at Bruce Power remained low compared to the Canadian industry. The Environmental Protection SCA covers programs that identify, control, and monitor all releases of radioactive and hazardous substances and effects on the environment from facilities. To ensure the protection of the environment and the health of persons, the CNSC conducts an environmental assessment under the NSCA for all projects within its mandate. CNSC staff completed an environmental assessment report, which was included in CNSC staff's written CMD. The environmental assessment report considers current operations and future activities, which include refurbishment. The report was produced using a number of different sources, which are shown in the right-hand side of the slide. CNSC staff concluded that the potential risks from physical stressors, as well as radiological and non-radiological releases to the environment, are generally low to negligible. In addition, Bruce Power's environmental risk assessment is consistent with the methodology described in CSA N288.6 on environmental risk assessment. The Emergency Management and Fire Protection SCA covers emergency plans and emergency preparedness programs. Bruce Power has the capability to respond effectively to any emergency. Bruce Power's emergency response plan covers both nuclear emergencies and conventional emergencies such as fire. An adequate nuclear emergency plan is in place. The plan is tested on a regular basis, which include conducting large-scale exercises. CNSC staff determined that Bruce Power demonstrated its response capability in the Huron Resolve exercise, which was discussed in Bruce Power's presentation. As part of the Huron Resolve exercise, Bruce Power tested out a DLAN system to provide plant information to CNSC Emergency Operations Center. CNSC staff require prompt and accurate plant information to independently understand the on-site situation and to predict the potential for radiological releases during emergencies. The DLAN system currently relies on human intervention to enter the data. A feasibility study is being undertaken by Bruce Power in 2018 to determine how this function can be automated. Bruce Power met regulatory requirements in the Security SCA. However, in 2016, Bruce A and Bruce B SCA ratings were downgraded to satisfactory based on challenges faced within the areas of security practice and drills and exercise. There have been no safety significant issues experienced with security equipment at Bruce A and B. Bruce Power demonstrated its ability to respond to security threats through a force-on-force exercise in 2016. There are measures in place to protect against cyber attacks. Bruce Power continued the implementation of CSA N290.7 on cybersecurity. The implementation will improve cybersecurity measures, including obtaining more cybersecurity assets. In addition to the performance assessment of SCA, CNSC staff identified other matters that are of regulatory interest. The next two slides focus on some of those matters. CNSC staff determined that Bruce Power has made significant progress in addressing Fukushima action items. A correction should be made to CNSC staff's written CMD, where only 3 of the 13 station-specific action items remain open. The external event hazard assessment that was identified as being open should be closed as Bruce Power performed the required assessment. All remaining actions are expected to be completed by end of 2022, as some of the improvements can only be made during a station outage. The earlier presentation by Bruce Power provided a brief summary of the Operation Safety Review Team, or OSART mission in 2015, and a follow-up mission in 2017. 18 of the 19 improvements are considered closed. The remaining improvement is related to drug and alcohol testing of key staff in safety and important roles, which was not a regulatory requirement in 2015. In March 2018, Bruce Power will submit an implementation plan on meeting this requirement. In 2006, a follow-up monitoring program was developed to verify the accuracy of the environmental assessment predictions of no significant adverse environmental effects from the Bruce A refurbishment project, and to verify the effectiveness of mitigation measures. In 2016, CNSC staff reviewed the final follow-up monitoring program report and determined that the follow-up monitoring program for Bruce A refurbishment project was concluded. Bruce Power will continue to perform environmental monitoring and assess future impacts such as thermal plume effects and entrainment of deep water sculpin as part of the environmental risk assessment. Bruce Power has a well-established public information and disclosure program. The program ensures that information about health, safety and security of persons and the environment were communicated to the public. The program demonstrates an open and transparent dialogue with their target audiences and stakeholders. In 2015, the Department of Fisheries and Oceans, or DFO, determined that there is a need for an authorization under the Fisheries Act. The Fisheries Act uses a different test than the environmental protection requirements of the NSCA and the Canadian Environmental Assessment Act of 2012. The process for obtaining a Fisheries Act authorization is separate from that of CNSC license renewal, as they are covered by different legislation. In 2013, a memorandum of understanding was signed between CNSC and the DFO, outlining areas for cooperation and administrations of the Fisheries Act. The CNSC will be responsible for the assessment and monitoring of the environmental impacts on fish, while the DFO remains accountable for issuing Fisheries Act authorization, including the offset measures. In essence, the DFO will determine the adequacy of the proposed offset projects. Bruce Power expects that the application will be ready to be submitted to DFO in the latter part of 2018, pending outcomes of the continuing discussion with the CNSC and the DFO. I will now discuss Bruce Power's specific requests made in its license application. The first request deals with the consolidation of other CNSC licenses with the Power Reactor Operating License. These licenses include the consolidated use of nuclear substance for laboratories and radiation devices, industrial radiography for non-destructive testing, and irradiator facility for instrument calibration. Bruce Power requested the consolidation because these activities result directly from and provide support for licensed activities at Bruce A and B. CNSC staff concluded that the proposed consolidation will not remove any regulatory requirements and will allow for more efficient regulatory oversight. All requirements from these licenses have been incorporated in the proposed Power Reactor Operating License. There is no reduction to the requirements or oversight as a result of the license consolidation. Now on to the second request. In its application, Bruce Power requested Commission approval to operate the units up to a maximum of 300,000 equivalent full power hour, or EFPH. Bruce Power is currently licensed to operate Bruce A and B up to a maximum of 247,000 effective full power hour, or equivalent full power hour, and hydrogen equivalent concentration, or HEQ, of 120 parts per million. These two limits are currently being met by Bruce Power. In order to meet refurbishment schedule, some units will be required to operate beyond the current EFPH and HEQ values. I will talk about HEQ in the next slide. To demonstrate fitness for service of fuel channels, Bruce Power provides life cycle management plans to manage the aging of components, inspection results from periodic inspection programs, control room procedures and protocols, which include information on how control room staff monitor the heat transport system for leakage, and industry operating experience and research. The licensee must also evaluate the effects of flaws and operating conditions on pressure tubes to confirm that the licensing bases are maintained, and demonstrate through safety analysis evaluation that the failure of a pressure tube will not impact the ability to safely shut down the reactor and prevent core damage. To summarize, there are adequate regulatory controls in place for ongoing confirmation of fitness for service for fuel channels. Before I go into detail on the work Bruce Power is performing to support operation up to 300,000 equivalent full power hour, I want to summarize the key points from the technical update CNC staff provided to the Commission on fuel channel fitness for service in Canadian MPPs, specifically on pressure tube fracture toughness. During operation, pressure tubes experience high temperature, high pressure, and neutron irradiation. They're also subject to corrosion and deuterium ingress effects. Of all the stressors, the dominant contributor to risk of pressure tube failure is increasing deuterium concentration, which has an impact on pressure tube fracture toughness. Deuterium concentration is measured in hydrogen equivalent concentration, or HEQ. Adequate fracture toughness is required to prevent a pressure tube rupture if a crack developed. Currently, Bruce Power, along with the Canadian industry, developed two fracture toughness models for HEQ levels up to 120 parts per million. These models are used in Bruce Power's assessment to demonstrate safe operation of pressure tubes in the unlikely event that a crack initiates and propagates through a wall of a pressure tube. Bruce Power has indicated that HEQ is estimated to reach approximately 150 parts per million prior to refurbishment, which is beyond the limits of the current model. Bruce Power has a plan in place to continue the development of the fracture toughness model up to HEQ of 160 parts per million. In addition, Bruce Power will perform ongoing monitoring of hydrogen content of pressure tubes. Finally, research and development work such as pressure tube burst tests will continue. Bruce Power must demonstrate to the CNSC that sufficient safety margins remain for the fracture toughness model for HEQ of 160 parts per million. This table was presented by Bruce Power earlier. It is important to note that Units 5, 7, and 8 will go beyond HEQ levels of 120 parts per million prior to the refurbishment dates. These units will not be allowed to operate unless fracture toughness model in excess of HEQ of 120 parts per million is developed. The estimated HEQ levels at the time of the MCR outage are within the bounds of the new model at HEQ levels up to 160 parts per million. Irrespective of the EFPH value, Bruce Power must demonstrate to the CNSC that fuel channels are fit for service to allow the continued safe operation of the units. CNSC staff recommend that the Commission approve operation of Bruce A and B up to a maximum of 300,000 equivalent full power hour based on, number one, Bruce Power will continue to operate its units within the licensing basis and maintain adequate safety margins. 2, degradation mechanism of pressure tubes are well known. And 3, Bruce Power has an acceptable inspection and monitoring program in place, specifically to monitor the HEQ levels. An established regulatory process, oversight process is in place to ensure that Bruce Power will meet its commitments. CNSC staff's recommendation is contingent on Bruce Power developing a fracture toughness model for HEQ in excess of 120 parts per million. Even though there's adequate regulatory oversight of this issue, for better transparency and to provide licensee with clear acceptance criteria, CNSC staff are recommending a license condition be placed on Bruce Power to maintain pressure tube fracture toughness sufficient for safe operation. The acceptance criteria for demonstration of fracture toughness are defined in the license condition handbook. The criteria clearly define the work that Bruce Power is required to perform, as well as define dates on when the work has to be completed. Bruce Power must meet the acceptance criteria. Otherwise, the units will not be authorized to operate. Bruce Power is also required to provide semi-annual update to the CNSC staff on the work progress. Finally, CNSC staff will report to the Commission on the status of work through the annual regulatory oversight report for NPPs. I will now pass the presentation back to Mr. Seguin to go over other CNSC activities that were involved in since the last license renewal.
Thank you, Mr. Lunn. Once again, it's Luc Seguin for the record. The CNSC's Independent Environmental Monitoring Program, or IEMP, was implemented to verify that public health and the environment are not adversely affected by releases around CNSC-regulated facilities. This verification is achieved through independent sampling and analysis by CNSC staff. The previous sampling campaign related to Bruce Power was carried out in 2016, with the next campaign scheduled for 2019. Detailed results of CNSC analysis are consistent with the results submitted by Bruce Power, and these are available on the CNSC's public website. As an agent of the Crown, the CNSC understands the importance of building relationships and consulting with Aboriginal peoples of Canada. The CNSC ensures that all its licensing decisions under the Nuclear Safety and Control Act uphold the honor of the Crown and consider potential or established Aboriginal and treaty rights. The Bruce site lies within the traditional territories of the Chippewas of Nawash Unceded First Nation and Saugeen First Nation, who together form Saugeen Ojibwe Nation, or San, as well as the Métis Nation of Ontario, MNO, and the historic Saugeen Métis, HSM. In September 2017, CNSC staff sent letters of notification to the Saugeen Ojibwe Nation, the Métis Nation of Ontario, and the historic Saugeen Métis, in addition to the Union of Ontario Indians and the Chiefs of Ontario. CNSC staff met with SAN, the MNO, and HSM to discuss the application, the process for getting involved, and to better understand their concerns related to the Bruce site. Follow-up information, including the license renewal CMD and the EA report, was sent to the groups in February 2018. CNSC staff have not identified any potential novel off-site impacts resulting from this license renewal application, but recognize that concerns related to impacts on fish have been raised by SAN and the MNO. CNSC staff and Bruce Power have continually engaged with SAN, the MNO, and the HSM, both individually and jointly, and will continue to do so throughout the life cycle of the facility. Bruce Power has a formal relationship with each of the groups through established protocol agreements. These agreements provide the framework for the continued collaboration between Bruce Power and each group. All of the identified Indigenous groups have been encouraged to participate in the review process and in the public hearings to advise the Commission directly of any concerns they may have in relation to this license application. The CNSC also continues to meet with Indigenous groups to encourage and maintain productive and respectful relationships. Finally, participant funding was provided to SAN and the MNO for meetings to work through issues of interest, such as the discussions on issues related to license renewal, refurbishment, and impacts of operations of the nuclear power plants on fish population. When the hearing dates were announced, a total of $100,000 was made available under the participant funding program to assist members of the public, Indigenous groups, and other stakeholders to participate in the review of the license application. Participant funding allows for the provision of new, distinctive, and valuable information to the Commission through informed and topic-specific interventions. A funding review committee that is independent from the CNSC was established to review the funding applications received. 8 applicants were awarded PFP funds to the amount of $76,500. These recipients will be providing interventions for Part 2 of these proceedings. CNSC staff conducted multiple outreach activities in the local Bruce communities. The activities included providing information on the CNSC licensing process and on Bruce Power's refurbishment project. The Bruce license renewal public hearing was communicated to members of the public. This included posting the notice of public hearings on the CNSC website, sending information to subscribers, and posting ads in digital and print media. CNSC staff made presentations to the local town councils, which included Bruce County, Kincardine, and Saugeen Shores. Discussions with the councils included, for example, the license renewal process, participant funding program, and key topics of interest for the Bruce licensing process. I will now briefly discuss the proposed license and license conditions handbook. It should be noted that these documents are considered draft and are subject to change prior to Part 2 of the Commission hearing. CNSC staff are recommending a 10-year license period. This is based on the following 2 factors. First, CNSC staff are recommending that Bruce Power be required to conduct a periodic safety review on a 10-year frequency. This aligns with international practice for PSRs. And second, Bruce Power has demonstrated continued satisfactory performance and a commitment to continue to improve performance in all safety and control areas. Annual reporting in the Regulatory Oversight Report for nuclear power plants to the Commission provides the public with frequent updates regarding CNSC regulatory oversight activities and Bruce Power's operation. The public has been invited to participate in these proceedings to present their views on the performance of the licensees. The wording of the license conditions for the 14 safety and control areas are standardized to allow consistent use across all Class 1 nuclear facilities. Each licensee will have additional license conditions which set out the requirements that are specific to the operation of that facility. For example, during the 2015 license renewal hearing, a license condition was imposed on Bruce Power requiring the licensee to inform the Commission of any plan to refurbish a reactor or replace a major component of the nuclear facility. The licensees are required to implement and maintain programs as approved by the Commission, which are referenced in the License Conditions Handbook, and they are required to operate within the bounds of the licensing basis set by the Commission. The license condition does not explicitly prohibit changes with a neutral or positive impact on safety. The changes shall be within the licensing basis and shall be made in accordance with the licensee's management program. There are currently a total of 26 CNSC regulatory documents referenced in the proposed License Conditions Handbook as compliance verification criteria. The full list of regulatory documents are found in the appendix section of the proposed License Conditions Handbook. 20 CNSC regulatory documents remain unchanged since last license renewal. A total of 6 new or revised CNSC regulatory documents have been added. In addition to the CNSC regulatory documents, there are currently a total of 25 CSA standards referenced in the draft License Conditions Handbook. 14 standards remain unchanged, 1 was updated, and 10 new standards are added in the proposed License Conditions Handbook. The License Conditions Handbook, or LCH, also contains additional regulatory documents and standards which are used by the licensee as guidance documents. There has been no reduction in regulatory requirements since the last license renewal. I will now pass the presentation back to Mr. Frappier for CNSC staff's conclusions and recommendations.
Thank you, Mr. Seguin. Once again, this is Jerry Frappier for the record. Based on the assessment of the Bruce Power safety performance, CNSC staff conclude that as per Section 24(4) of the Nuclear Safety and Control Act, Bruce Power is qualified to carry out the activities authorized by the license, and in carrying out the licensed activities, Bruce Power has made and will continue to make adequate provisions for the protection of the environment, the health and safety of persons, the maintenance of national security, and measures required to implement international obligations to which Canada has agreed. CNSC staff recommend that the Commission accept the conclusions and recommendations presented in CMD 18H4 and exercise its authority under the Nuclear Safety and Control Act to renew the license and to authorize Bruce Power to continue to operate the Bruce A and B nuclear generating station for a period of 10 years from September 1st, 2018 to August 31st, 2028. CNSC staff also recommend that the Commission consolidate the license for industrial radiography, the Class 2 irradiator facility, and consolidated use of nuclear substances into the power reactor operating license. Finally, CNSC staff recommend the Commission to authorize Bruce Power to operate Bruce A and B up to a maximum of 300,000 equivalent full power hours. Furthermore, CNSC staff recommend that the Commission place the following conditions on Bruce Power as part of the license renewal. Implement the integrated implementation plan resulting from the periodic safety review supporting this license renewal application. Demonstrate that the reduction in fracture toughness of the pressure tubes does not impact safe operations. Implement a return to service plan for refurbishment activities. Obtain authorization from the Commission or a delegate to remove regulatory hold points during the return to service. And finally, conduct another periodic safety review as part of the next license renewal in 2028. CNSC staff also recommend that the Commission authorize the delegation of authority as indicated in two proposed license conditions on this slide. The first is license condition 3.2 for restart after serious process failure, and the second is license condition 15.5 for the removal of regulatory hold points related to return to service. The Commission may delegate authority to CNSC staff with respect to the administration of license conditions or portions thereof. And CNSC staff recommends that the authority be delegated to the Executive Vice President of the Regulatory Operations Branch. This is the same as what has been delegated for other power reactor operating licenses such as Point Lepreau and Darlington. Again, CNSC staff recommend that the Commission accept CNSC staff's conclusions and recommendations presented in CMD 18H4 and exercise its authority under the Nuclear Safety and Control Act to renew the license and to authorize Bruce Power to continue to operate the Bruce A and B nuclear generating station. Thank you, Mr. President and members of the Commission. We're prepared to respond to any questions you may have.
Thank you.